Right. So let's just do a quick recap of this. So what you have here is the double slit interference experiment. So আমি পুরো জিনিসটা আরেকবার হচ্ছে recap করি what's going on here. So you have a light source here, and there's this single slit here. And as the light passes through the single slit, it undergoes diffraction. So it spreads like that. And the light then goes and reaches the screen. And we find that the brightest part of the screen is at the center because the light has traveled the shortest distance there. And the further and further you go away, the light starts to fade out, right? And this is how the graph looks like. This is the intensity versus distance graph, okay? Now, the thing is, this is for just a single source passing through a single gap, right? However, this person who did the experiment thought of an idea. What he wanted to do was to use two slits here like that. And duita slit use করে, the outcome was little fascinating. The outcome looked something like this. So you had a bright spot at the center, but you had dark, bright, এরকম জিনিস হচ্ছিল. And these dark, bright spots that you see here, these are referred as fringes. So যেটা হচ্ছিল স্ক্রিনের মধ্যে, there was formation of fringes. So these are called fringes. So a dark, bright fringes are forming here, right? So the question was then, why is the dark, bright fringe pattern forming here? And we discussed that last class. So essentially, jeta hoy is that light travels from one of these gaps to a certain point. So ধরো যে light এখানে travel করলো, light এখান থেকেও এখানে travel করলো, and as the light travels from here to that point and from here to that point, it results in a path difference. So what happens is there's a difference in the length they travel. And because of the difference in the length they travel, when they interfere or meet here, they result in constructive and destructive interferences, right? So what we have noticed is that in these scenarios, like for example, here, if your light has traveled 12 wavelengths this way and 12 wavelengths that way, the path difference is 0. So what happens is when your path difference is 0, you end up with a constructive interference. আবার দেখা যাচ্ছে লাইটটা, so light কিন্তু সব দিকে travel করতেছে. I showed this last class that there's light traveling everywhere. So there are places where the light travels a certain distance and the path difference is like a half multiple, like 0.5, 1.5, 2.5, and that results in destructive interference. So at the end, the idea is that when light reaches the screen, there are places where the light is completely in phase or constructive interference, and the light is completely out of phase or destructive interference. And because of that, you have this dark, bright pattern formation. So this is the reason why you have this double slit interference pattern forming here, right? Fringe pattern. Now, some things that you have to be very careful about. The light source that we use here has to be monochromatic. So monochromatic mane hocche, it has to be of a single frequency. Okay, so this is single frequency, monochromatic source. And the idea is that when you have a monochromatic source, naturally, the light that goes through this gap and the light that goes through that gap would be coherent. So coherent light sources. Coherent now, you won't have the formation of constructive destructive interferences, right? So yeah, that's the idea used here, and this is how the graph looks like. So you'll have a peak at the center, and the further you go, a peak kome jay. I think we discussed that last class again. It's mentioned here. The intensity decreases as the peak starts to fall as well. Okay, so this is what we saw last class. I'll show you the formula. So what's the formula related to this topic? So let's have a look at that. Okay, so there's an unfortunate turn we're going to take right now. So this double slit interference experiment was used to find the wavelength, finding the lambda of a light source. So it became famous because you find the lambda of the light source using this setup. How is that? So there's a derivation of that because it's beyond the scope of our syllabus. But from so derivation derived for this particular equation. So let me show you what the formula is. So when you have two slits here, আমাদের এই particular experiment, this gap that you see here is very important. The gap between the center to center of two slits. This gap. And this gap is referred as A. এটা হচ্ছে এই গ্যাপটাকে আমরা A, small a দিয়ে represent করি. What does this gap stand for? It is called slit separation. Slit separation is the distance between two slits in your setup. Okay, so এটা হচ্ছে A refer করা হয়, slit separation বলা হয়. You have to take it from the center to the center. That's important, okay? Not from left to right or top to bottom, center to center. So this is called slit separation. And তারপর we have to place a screen. So you have your screen placed somewhere here, right? So the distance at which the screen is placed, right? This distance at which the screen is placed is very important. It's capital D. So distance of the screen. So এটা হচ্ছে that distance. And what happens is once you do this experiment, right, you'll find that তোমার এখানে হচ্ছে dark and bright pattern form হচ্ছে, right? So you'll have dark and bright pattern here. আমি জিনিসটাকে এভাবে বুঝাই. So you'll have like a central bright spot. তারপর you'll have dark spot, our bright spot. So আমি just bright spot গুলো draw করতেছি, okay? So these are your fringes. Now turns out they play a very important role here. Let me show you key. So right, so these are your fringes. The distance between two fringes, right, is very important for us. It is called X, and it is referred as the fringe separation. Okay, fringe separation. So you have A here, D here, X here. These are the three quantities that we have. So apparently, using a derivation that we don't have in our syllabus anymore, you can use these three quantities and come up with a formula, which is lambda wavelength. Lambda equals to AX by D. And the reason why this equation was very famous is because you can find the wavelength of a light source, which by the way is a very small wavelength, just by measuring few things in your experiment. So তোমার experimenter মধ্যে তুমি যদি হচ্ছে A, X and D measure করো, it'll give you your wavelength. And that's very handy because lighter wavelength বের করার কোনো উপায় ছিল না back then. Now we have other ways, but back then there weren't any ways to figuring that out. That's why it was very famous. So this is your wavelength of your source. Doesn't need to be light, by the way. It could be anything. Wavelength. This is your slit separation. And yeah, I mean, এখান থেকে question আসলে mostly MCQ আসে, and I'll explain why it takes an unfortunate turn and বলছিলাম তো that something happens here, right? So তোমাদের খুব সুন্দর formula দেওয়া আছে, সবকিছু দেওয়া আছে এখানে, and then ওরা decide করে to do something. I'll tell you what they decide to do. But the slit separation, this is your fringe separation, but with a fringe distance, and this is the distance of the screen. Distance of screen. Acha. So what's the catch here? Catch হচ্ছে you can't use this formula all the time. There's a particular condition that has to be met for this formula to be applicable. And the condition হচ্ছে A has to be smaller, smaller, smaller than D. Or as they say, A must be significantly less in size compared to D. What does that even mean? Okay, let me explain. So generally, one less than sign means it's less than, obviously. Now in math, if you put multiple less than signs, it means it's multiple magnitudes less than. So what it means here with three less than sign is that A, our D ratio, has to be approximately 1000. So A has to be, has to be approximately 1,000 times smaller than D. Now, you might be wondering why. So, unfortunately, the derivation is not there in our syllabus, but derivation করতে গেলে এই assumptionটা করতে হয়। এই assumptionটা যদি করো that A is very small compared to D, then only this equation works. Otherwise, কাজ করে না. So, at the end of the day, what is the thing that you need to remember? You need to remember, for example, তোমার যদি A 1 centimeter হয়, তাহলে তোমার D has to be around 10 meters. এই রেশিওটা মেনটেন করতে হবে। সো তোমার স্লিট সেপারেশন যদি 1 centimeter হয়, your screen has to be 10 meters apart. Then only you will have data that can be used in this equation. Otherwise, the equation they use করা যায় না. Okay, so overall, once you see the types of question given in your exam, none of the questions they provided in the last 5 years actually meet this criteria. So if the equations, the information provided does not meet this criteria, what does that mean? You can't use this formula. তখন কেমনে wavelength বের করতে হয়? That's what I'm going to show you now, and that is a 5-mark answer. Okay, so তোমার যদি এই questionটা আসে, এটা যদি use করতে দেয়, it's probably 1 mark, 2 mark, MCQ, something like that. But যদি এই questionটা applicable না হয়, the alternate, right, is like a 5-mark thing that we're going to do next. Okay, so this is the equation process, like equation use করে. So yeah, if you have questions, ask me right now. Also, I just want to know, যদি কারোর স্কুলে waves করায় থাকে, derivation থেকে করাইছে নাকি? কারণ derivation actually খারাপ না. I personally like the derivation, but the derivation requires knowledge of math that's beyond the scope of AS syllabus. It's like further pure math বা ওরকম একটা chapter লাগে. So তার জন্য I don't want you to burden with something that's, you know, beyond the scope of what you know. Right. So once again, if you want this to be a successful experiment, তোমার যে slit separationটা মানে যে gap গুলো থাকবে has to be of such a size that it's 1,000 times smaller than how far the screen is. So simply put, তোমার যদি গ্যাপটা 1 centimeter হয়, your screen has to be 10 meters apart. Okay, so that's the ratio you need to maintain. কেন ratio maintain করতে হবে? If you want to use this formula, a formula use করতে হলে ratio to maintain করতে হয়, otherwise the formula doesn't work. Right, so if you guys have any questions, বলতে পারো আমাকে। Recap about the setup. যে সেটআপটা এটাই, এই সেপারেশনটা অনেক ছোট হতে হবে compared to how far the screen is. So তোমার যদি slit separation হয় 5 centimeters, let's say, আর স্ক্রিনটা হয় 20 centimeters দূরে, তাহলে এই ফর্মুলা কাজ করে না। মানে ফর্মুলাতে ভ্যালু বসাবো, দেবা কারেক্ট অ্যান্সার আসে না। Also, this formula has a drawback. It's only good for light, sound, microwaves, other type of waves. দেখা যায় ফর্মুলাটা ভালো কাজ করে না। কেন আমি বলি? কারণ সাউন্ডের ওয়েভলেন্থ যা, ওইটার জন্য the fringe separation massive হয়, মানে একটা রুমের সমান সাইজ হয়। So which means that you need to place your screen like 200 meters away. 200 meters মানে হচ্ছে 2টা ফুটবল স্টেডিয়ামের লেন্থে রাখতে হবে if you want to use the formula with sound, which doesn't really make sense because sound এত দূরে যাবেও না, so eventually দেখা যায় কাজে দেয় না। So what's the range for difference? 1,000 and more. So 1,000 থেকে বেশি হলে ভালো, 10,000 হলে আরো ভালো, 100,000 হলে তো আরো ভালো, but around 1,000 minimum maintain করতে হবে, 1,000 times. So যে তোমাদের estimator question আসে না, estimator question প্রায় এটা জিজ্ঞেস করে যে what should be an appropriate distance of the screen. So, you know, a few meters would be better. So do we assume a big number and work our way through the formula if we get questions on this? No. So if you want to use the formula, right, the information provided has to match this criteria. So what if it doesn't match this criteria? You can't use the formula. There's nothing you can do about this. So you have to do it in a different way, which I'll teach you right now. So the formula is very limited. At the end of the day, the formula only works if the setup is perfect. And the way the syllabus is, they very rarely give you a perfect setup. Right, so let's look at the alternate. So the alternate is called, there's no name for it, but I will be calling it the manual method. So finding the wavelength using manual method. This manual method doesn't have any restriction. You can use any size and whatnot. So how does the manual method work? So manual method টা হচ্ছে এভাবে কাজ করে. So let me show you কি হচ্ছে. Pay attention here. These are some of the highest mark questions in your waves chapter. আচ্ছা 5, 4 marks এইসব question থেকে আসে. So let's say I have a double slit interference setup here, okay? And the distance between my two slits here is A, slit separation, right? And I have my screen here, but unfortunately my screen is not far enough to a ratio of 1:1000. Our screen is actually pretty close. You can say it's in the ratio of 10. Our separation ratio at 10 times. 1000 হওয়ার কথা ছিল না? So D is not really big. So will interference pattern take place? Yes, of course, কেন হবে না? So কি হবে এখানে? You'll find যে যদি interference pattern হয়, let's say use blue light or violet light, এই center দেখবা যে you'll have a very nice bright spot here, মাঝখানে, right? That's the central maxima, and then it'll fade away to darkness, and then you'll see nothing there. And then again, my darkness will come back to the brightness. So এরকম dark and bright fringe pattern কিন্তু পাবো, কোনো problem নাই. So ওরা যেটা চায় is for you to find the wavelength right now, but you can't use the formula. So how can I find the wavelength if I'm not allowed to use the formula? So see কি করা হয় এখানে. So what we do here is we find the maximas. So let me explain কি করতে হয়. So you first note down এটা কি maxima. So can you tell me the one at the center is known as what maxima? Right at the center যেটা থাকে, what do we call that? Central maxima, correct. So the one that you see at the center is called the central maxima. Do you recall the central maxima টা attain করতে হলে my light would have traveled here and my light would have traveled there? And what would the path difference need to be in order to achieve the central maxima? 0. Very good. আচ্ছা, but আমার দরকার হচ্ছে wavelength বের করা. So আমি যেটা করব, I will move to this spot or any other spot, but এই spotটা choose করলাম আমি. Can you tell me what maxima is this? What maxima is this? First or second maxima? Very good, second maxima. কেন? Because center to the 0, তারপর এটা হচ্ছে 1, তারপর এটা 2. This is my second maxima. Can you tell me second maxima মানে হচ্ছে what is the path difference between the two lines? Very good, 2 lambda. So ভালোই বুঝছো দেখি, 2 lambda, which means আমার এখান থেকে wave travel করে and they reach this point. আমার এখান থেকে wave travel করে and they reach that point. How many extra waves do I have in one of the lines? 2 extra waves, right? So যদি আমি এটা এভাবে করি, দেখো, I don't know how many waves are here. আমার কোনো আইডিয়া নাই, আমার এখানেও কোনো আইডিয়া নাই কয়টা ওয়েভ, এটা কাউন্ট করা সম্ভব না. But I know যে whatever the number of waves would be, this line, the longer line, has how many extra waves? 2, right? So আমাদের এখানে যেটা করতে হয় is we need to measure the length of the both the path. So যে এটা measure করব, let's call it L1, and I'll measure this one L2 or X1. No, X to এটা ধরো L1 and এটা হচ্ছে L2. I have a question for you. আচ্ছা, তোমরা দেখো অ্যানসার করতে পারো নাকি? যদি অ্যানসার করতে পারো then the work is done actually. L1 minus L2 is equal to path difference, right? That's what path difference actually means. Can you tell me for second maxima L1 minus L2 equals to what? 2 lambda, very good. Therefore, what would lambda be? L1 minus L2 divided by 2. বুঝছো জিনিসটা? And this is how you do it manually. This is called the manual method. এটা অনেক খাটনি করতে হয়। কেন খাটনি করতে হয়? তোমাকে একটা মেজারিং টেপ নিয়ে এই লেন্থটা মেজার করতে হবে, আর একটা মেজারিং টেপ নিয়ে এই লেন্থটা মেজার করতে হবে, তারপর তোমাকে বের করতে হবে এটা কোন নাম্বার ম্যাক্সিমা, যাতে তুমি জানো যে এই লেন্থটা আর এই লেন্থটার ডিফারেন্সটা আমাকে দিবে 2 lambda. So if I zoomed in here, right, and if I drew this accurately, I would find that for 2 lambda I have 2 extra waves here. So আমি যদি এক্সট্রা গ্যাপটা somehow খুঁজে বের করতে পারি, তাহলে আমি ওয়েভলেন্থ বের করতে পারি। আর এটা কোনো ফর্মুলা ইকুয়েশন কিছু লাগে না। ইটস কল্ড দ্য ম্যানুয়াল মেথড। এটা তুমি জাস্ট হচ্ছে ম্যানুয়ালি করে করবা। Why can't we use first maxima? Very good question. Why can't we use first maxima? Can anyone tell me, can I use first maxima? Yes, of course. না কেন ইউজ করা যাবে না? ফার্স্ট ম্যাক্সিমাম ইউজ করলে আমার L1 minus L2 কি দিবে? ল্যামডা। Second maximum কি দিবে? L1 minus L2 is 2 lambda, right? So can anyone tell me why would I prefer higher maxima? মানে আমি এখানে সেকেন্ডটা নিলাম না, রিয়েল লাইফে আমরা 7 8 খুঁজি, যত দূরে যাওয়া যায় তত বেটার। Why would we prefer like further away? What's your understanding? Yes. দূরে গেলে সুবিধাটা কি? ওই রিডিং গুলো বাড়বে, and as you know in physics, a bigger reading leads to what? Revision. A bigger reading, a larger reading leads to what? Lower percentage uncertainty. Accuracy এগুলা কিছু না, কিন্তু lower percentage uncertainty. মনে আছে? That's why we take more readings, we fold things, we take multiple cycles, right? So বড় reading এ আমার হচ্ছে uncertainty percentageটা কম হয়, which eventually leads to more accuracy, I admit that, but the main idea is to reduce the percentage uncertainty. So আমার যদি হচ্ছে let me give you a simple example. Acha, if I take this difference, it's like 0.001, অনেক ছোট একটা নাম্বার, আমার স্কেলে ভালো দেখা যাচ্ছে না। বাট আমি যদি এটা নেই আর এটা নেই, it's like 0.5, যেটা আমার স্কেলে ভালো দেখা যাচ্ছে। So wouldn't that be much better for me to read, and wouldn't that give me a lower percentage uncertainty? So that's why we try to take bigger readings. The only can you tell me which maxima can't we take? মানে ওটা নিয়ে কোনো কাজে দিবে না, there's only one of them. Which one? Which maxima is useless here for this kind of question? Yeah, central. কারণ সেন্ট্রালের প্রবলেম কি, তুমি লেফট রাইট থেকে যাবা সবসময় ডিফারেন্স জিরো দিচ্ছে। এখন ইউ হ্যাভ নো ক্লু কিসের ডিফারেন্স জিরো, মানে এটা কি 1000 এর ডিফারেন্স জিরো, নাকি 5 আর 5 এর ডিফারেন্স জিরো? আসলে সেন্ট্রাল ম্যাক্সিমা দিয়ে কাজ করা যায় না। আর একটা কোয়েশ্চেন, ডু ইউ থিঙ্ক মিনিমা দিয়ে কাজ করা যায়? Can I use minima here for this math? Yeah, of course. I'll go to a minima, it'll give me like, lambda by 2, 3 lambda by 2, 5 lambda by 2, সবই করা যায়। Personally, I prefer যে হচ্ছে মিনিমাটা নেওয়া, কারণ মিনিমা গুলো হচ্ছে ইজিলি বোঝা যায়, ফুল ডার্কনেস থাকে, so you can pick them up more easily. But I've seen question paper ওরা দুইটাই করে, so practically speaking, minima would have been better. Okay. Right, so this is the manual method, and this is the equation method. The equation method is only applicable for this criteria. Okay, এটা হলো only applicable then. Our manual method for any scenario. Yeah, যদি minimum হয় তাহলে L1 minus L2 would be lambda by 2, but lambda by 2 depends on which minimum you will for. Right, so let's practice some questions. I'll add notes first, and then we'll practice the question. Basic notes here. One of them is this one. This is the candle fringe pattern form by that. My fringe pattern form. Right. So why fringe patterns are formed are then note diagram actually. Okay, like a question day. Questionটা করে তারপর I'll elaborate a little bit more on this idea. We're done with double slit interference, by the way, but question না করে বুঝাটা যায় না, so practice question. Right, so একটা question দিচ্ছি to try করো example. Some very challenging questions of waves এইখান থেকে আসে, okay? So a double slit interference question practice করলে আর to better হবে তোমাদের, but right now I'm just showing the basic because question গুলো যে টাইপের চ্যালেঞ্জ দেয় ওইটা actually এখানে দেখানো পসিবল না, কোয়েশ্চেনের মাধ্যমে করতে পারবা। Right, so screen-এ সবাই দেখো what's going on here. So the separation between the two slits here is 40 centimeters. The distance of the screen here is 2 meters, and the student finds that এখানে you have a bright spot, okay, and then you have a bright spot, and then you have a bright spot, and a bright spot, and a bright spot. So these are all bright spots out there. And the student finds that the distance between the central bright spot and that bright spot at the top, right, that bright spot is 75 centimeters, okay? So these are all the bright spots that you have on the screen. এখন তোমাদের যেটা করতে হবে is very straightforward. Find lambda. করো, আর কিছু বলবো না তোমাদেরকে। So একটা experimented, the slit separation was 40 centimeters, the screen was 2 meters apart, and on the screen the bright spots were produced, as you can see here. These are the bright spot. Yeah, this is the central one, যেটা তুমি দেখতেছো একদম মাঝখানে. This is the central maximum, এটা বলে দিচ্ছি তোমাদেরকে. So this is your central maxima. So yeah, what you need to do is find lambda. করো, পারবা আমি জানি, ট্রাই করো, হয়ে যাবে। 3.75 meters to be sure. Are you guys using the formula lambda equals to ax by d? Formula কি ইউজ করছো কেউ? নো, ফর্মুলা ইউজ করা যাবে না তো, কারণ আমার সেপারেশন হচ্ছে 0.4 আর আমার স্ক্রিন হচ্ছে 2 meters apart. Isn't this ratio nowhere close to 1000? আচ্ছা, ফর্মুলা যদি ইউজ করে থাকো রাখো, I'll prove you how wrong the formula is, but formula দিয়ে হবে না, you have to do it differently. But I'm surprised, why did some of you use the formula? Formula applicable na to. Didn't they say formula requirement hoche that the slit separation has to be 1,000 times smaller than the distance of the screen? 40 centimeter ki 1,000 times smaller than 200. What math is that? $3.5. Okay, let's do this. So some of you have questions যে আমরা তো length জানি না. That's the whole point of the question. So দেখো কি হচ্ছে এখানে. So আমাকে যেটা বের করতে হবে is I need to figure out 75 centimeter কি represent করে. So can you tell me 75 centimeter মাথায় যে like at the top যে maximum আসছে, like this one, what maximum is this? Can you tell me what maximum is that? Oh no, fifth maxima. এত কিছু করার পরে fifth maxima হলো এটা. 0 1 2 3 5. That's fourth maxima. Anyways, এখন আমাদের যেটা বের হবে যে if I draw a line from here to there, right? এই লাইনটার length যা, and if I draw a line from here to there, what is the difference in the length of these two lines going to be? 4 lambda. Very good, right? So তোমার যদি এখানে ডিফারেন্সটা বের করো, তুমি যদি এই যে ইকুয়াল লেন্থ কভার করতে, তুমি এখানে যদি চেক করতে, you will find there's 1 2 3 4 extra waves out there. So আমাদের যেটা এখন করতে হবে is find the length of the red line and find the length of the violet line and find the difference in these two. 4 lambda কেন আসছে? এই যে central maxima is when light from here and there has 0 path difference. First maxima is when the line from here to there has 1 lambda path difference. Second maxima is when the line from here to there has 2 lambda path difference. Third maxima is when the line from here to there has 3 lambda path difference. And fourth maxima is when the two lines have a path difference of 4 lambda. And 4 lambda, 3 lambda, 2 lambda, 1 lambda all result in a maxima, a bright spot. So আমাদের এখানে যেটা করতে হবে এখন is trying to figure out what the length of the red line is. And that is not physics, it's math. Okay, I'll explain how. So আমি যদি এখানে একটা triangle create করি, this is 40 centimeters, right? So আমার এই যে a extra gap যেটা এখানে is going to be 20 centimeters, and that extra gap there is going to be 20 centimeters. 40 equally split হয়ে যাচ্ছে, right? So if this whole thing is 75 and this is 20, how much should the height be? That's going to be 75 minus 20, 55 centimeters. And my base is 2 meters. So that's 200 centimeters. So let's call this L1. Sorry, L2. Can somebody tell me what is the value here? 200 squared plus 55 squared root over কত আসে? 207.4 centimeters. Okay, fine. এখন পার্পলটার জন্য করব আমরা। সো পার্পলে যেটা হবে is purple হচ্ছে this is again 200 centimeters, and আমার এই এটা extra 20 add হবে নিচে, so that's going to be 75 plus 20, that's 95 centimeters. So L1 is going to be how much? 221.4 centimeters, right? So we know that whatever the lengths are, the difference would be equal to 4 lambda, right? So therefore, L1 minus L2 equals to 4 lambda. That's 221.4 minus 207.4 equals to 4 lambda. So therefore, lambda is how much? 3.5 centimeters. Okay. And যারা formula use করছে তোমাদের কি আসছিল? 3.75. Right. So do you see the difference? It's a substantial difference কিন্তু মানে তোমার মনে হবে কাছাকাছি, but it's actually not কাছাকাছি. So this is the right value. ওই ফর্মুলাটা এখানে কাজ করে নাই। Are you guys clear? A process it's called a manual method. If you can master this, you'll find questions are much easier. All right, so I think we're out of time. This is the double slit interference experiment and also the entirety of the topic. Our next class হচ্ছে diffraction gradient শুরু করব as a last part of our waves chapter. তারপরে হচ্ছে হলো আমি ওই review questions গুলো skip করে electricity start করব because I just want to wrap up the syllabus, and by looks of it হয়ে যাবে এই month-এর মধ্যে, then I'll just start doing revision. Okay, so তখন আমরা ওই question গুলো করব. So yeah, we are almost done with waves. Waves গুলো একটু পড়ালেখা করো, because waves আমি আগে থেকে বলে দিচ্ছি, if you can somehow tackle waves, right, you'll have like a very good AS. If you struggle with waves, you'll have a questionable AS. Okay, so waves এখনো time আছে, you have like January, February, March, April, May first week তোমাদের পরীক্ষা. So I think 4 months is enough for you to study waves. Don't wait for the last week. Okay, এখন থেকে waves এর question paper গুলো start করো, start doing your MCQs. আমি যদি test নেই, mock নেই in the last week of this month, I'll focus on entirely on waves. Okay, in fact I might only take mocks in the future that are just waves and electricity, অন্য কিছুগুলো অত করব না, because it matters a lot, a wave and electricity chapter. Subtopic হচ্ছে stationary waves and double slit interference. These two are the most important ones. Doppler effect, intensity, polarization, ওগুলো অত important না, but a stationary waves are সবচেয়ে important, and then a double slit interference the second important. তারপর হচ্ছে which one should you do, MCQ or MCQs? For you guys are very lucky Cambridge, because MCQ গুলো খুবই ভালো কোয়ালিটির হয় তো, so if you can figure out the MCQs, theory-তে কোনো problem হবে না। And eventually students struggle করে MCQ তে, so MCQ is the focus always. So if you can figure out MCQs, theory is not going to be an issue. মক হচ্ছে পেপার 1 পেপার 2 হবে, দুইটাই হবে। এখন থেকে মক গুলো পেপার 1 পেপার 2 করেই হবে। Mock is 27th. Next one. All right, so we'll continue rest next class, okay?